beneath the 600 metres of ice below me is the most important point of all.
While it's commonly said that calm waters hide mysteries beneath, the vastness of the ocean holds some of the most unexpected wonders. Exploring the depths of our planet's seas has always been a journey into the unknown, revealing countless marvels. While conventional wisdom suggested that the frigid, nutrient-deficient waters beneath Antarctica's ice shelves couldn't support much life, a recent study, spearheaded by Elon Musk, challenges this notion. Surprisingly, researchers uncovered a thriving colony of creatures on the seafloor, defying all expectations and leaving scientists scrambling for explanations. What exactly did they find in the unfathomable depths, and what does this revelation signify? Let's delve into the extraordinary discovery made in the Arctic. Back in 1958, a historic moment unfolded when a US submarine ventured beneath the ice, marking the first ever voyage to the North Pole. This groundbreaking mission not only made history but also opened up a new realm for scientific exploration. Today, nuclear-powered submarines stand as formidable tools of defense, equipped with torpedoes and nuclear missiles, capable of extended missions lasting months. For example, the UK has maintained a continuous presence of such submarines since 1969. Beyond their military role, these submarines have become invaluable assets for scientific inquiry, shedding light on the mysteries of the Arctic's icy depths. The mission served as a dual-purpose endeavour, testing the military capabilities of nuclear submarines while simultaneously advancing our understanding of the Arctic environment. Both the Navy and scientific communities have benefited from the insights gained through these expeditions. By venturing into hostile environments, submarines provide crucial data that helps us comprehend the present conditions and anticipate future changes. In essence, they serve as portals to a world that is as enigmatic as it is essential to our understanding of the planet. Antarctica, renowned as the coldest continent, holds a wealth of enigmatic mysteries waiting to be unveiled. Beneath its icy expanse lies a trove of strange and awe-inspiring anomalies, yet to be explored. Even amidst the desolation and harsh conditions of the Filchner-Ronne ice shelf, located 5 hours' flight from the nearest outpost, adventure thrives. Geologist James Smith, part of the British Antarctic Survey, braved over 3 months of sub-zero temperatures, enduring nights in a tent and subsisting on dehydrated rations. Despite the summer season in the south, Smith faced a daunting task: retrieving seafloor sediment buried beneath half a mile of ice to study the shelf's history. The scientific process proved arduous. Smith and his team melted 20 tons of snow to obtain 20,000 litres of hot water, which they painstakingly funneled through a pipe lowered into a borehole. After chipping away at the ice for 20 grueling hours, they finally broke through the shelf. Their efforts, however, yielded unexpected challenges. Despite repeated attempts, their sediment collector returned empty-handed. Undeterred, they persisted. Upon reviewing footage captured by a GoPro camera lowered into the borehole, Smith made a startling discovery. The video revealed a plunge through thousands of feet of bluish-green ice, unveiling the deep ocean below. Amidst the seafloor's predominantly light-coloured silt, a dark anomaly caught their attention. A lone boulder, stark against the flat expanse. As the camera descended further, the boulder revealed an astonishing secret: signs of life. Perplexed by this revelation, Smith sought the expertise of his colleague, biologist Hugh Griffiths. Griffiths identified a film on the rock, likely composed of microorganisms known as microbial mats. In a landscape where every endeavour is fraught with challenges, Smith's expedition unearthed an unexpected twist, highlighting the resilience and adaptability of life even in the most extreme environments. While robust cylindrical sponges clung to the surface, an oddly alien-like sponge and other lurking creatures adorned the rock. Delicate filaments, possibly part of bacterial mats or a peculiar hydroid creature, adorned its surface. Remarkably, this rock, stumbled upon by Smith, sits a staggering 160 miles from the nearest edge of the ice shelf where the open ocean begins. The closest potential food source lies hundreds of miles away, where ample sunlight fuels a thriving ecosystem nourished by ocean currents. According to prevailing theories, life diminishes as one moves away from the open sea and sunlight, particularly beneath ice shelves. Previous studies uncovered small mobile scavengers and predators like fish, worms, jellyfish, and krill in these environments. However, the presence of filter-feeding species reliant on external food sources defies expectations. "It truly has no reason to be here," remarked Griffiths. "At first glance, it's just an unassuming rock, unless you understand its context." Now that you're aware of its significance, you might find yourself astonished beyond belief. The discovery raises a plethora of questions, one of which is how these organisms ended up in such an isolated location. What sustains their diet? How long have they been thriving there? And how common are these covered boulders in nature? Are they the same species found outside the ice shelf, or are they a distinct variation? Additionally, what would be the fate of these communities if the ice shelf were to collapse? These creatures dwell in complete darkness, akin to many deep-sea organisms. However, unlike mobile deep-sea inhabitants, those living a sedentary life on the seafloor require a consistent food source, typically in the form of marine snow. Marine snow comprises organic matter that sinks from the water column above, generated by decaying organisms and debris. This process sustains life in most regions around Antarctica, where the seas teem with productivity, supporting a complex food web. However, the Antarctic organisms on this particular rock reside beneath a thick layer of ice, isolated from the bustling water column above. Unable to forage for food, they face a challenging predicament. According to Griffiths, being immobile in a food-scarce environment is far from ideal. So, how do they nourish themselves? Researchers speculate that the horizontal drift of marine snow might provide a solution, albeit in an unconventional manner. After scrutinizing current charts near the drill site, the researchers pinpointed fertile zones located between 390 and 930 kilometers away. Though seemingly distant, these regions could be vital conduits for organic material, potentially spanning hundreds of miles to sustain the creatures observed. To grasp the magnitude of this phenomenon, consider that marine snow, originating at the surface, must descend a staggering 7 miles to reach the ocean's deepest point, the Challenger Deep near Guam. Astonishingly, food would need to travel up to 133 times that distance, drifting laterally to reach the creatures inhabiting this Antarctic rock, as explained by Rich Mui, curator of invertebrate zoology and geology at the California Academy of Sciences. Mui elucidates that such a scenario isn't implausible, given our understanding of the currents surrounding Antarctica. As seawater cools, it becomes denser and descends to the ocean floor, before radiating outward from the Antarctic continent, influencing global current systems. Consequently, these currents create a flow of organic matter, replenishing ecosystems even over vast distances. This influx could sustain the life forms ensconced on the isolated boulder. Moreover, these currents might introduce new species to the rock's animal community. However, without samples, the researchers remain uncertain about the precise diet of the sponges and other inhabitants. While some sponges are carnivorous, preying on small organisms, others sift organic particles from the water column. That would undoubtedly make for a headline of the year, remarks Christopher Marr, a marine biologist at the Smithsonian who wasn't involved in the research. Killer sponges thriving in the dark, frigid depths of Antarctica, where conventional wisdom dictates no life could endure. Since the camera failed to capture any fish or crustaceans, Griffiths and his team remain uncertain about the presence of other mobile species in the vicinity of the rock. This ambiguity extends to whether the sessile animals are vulnerable to predation. Do they all rely on the same food source, or perhaps some share nutrients? Or are there additional wandering creatures supporting this colony in some manner? These questions can only be answered through further exploration. Fortunately, the animals seem safe from burial, as the sedimentation surrounding the rock appears relatively light. It's a bit like a Goldilocks situation, notes Griffiths, referring to the rock's seemingly fortunate placement. It receives just enough food, faces no apparent threats from predators, and isn't overwhelmed by excessive sediment. The discovery of ripples in the sediment surrounding the rock lends credence to the notion that food is transported from a distance. However, the origins of these stationary animals remain a mystery. Did they originate locally, perhaps moving from one nearby boulder to another? Alternatively, it's conceivable that their ancestors resided on rocks thousands of kilometers away, where a more typical marine ecosystem exists at the edge of the ice shelf, releasing their reproductive cells to drift with the currents. Griffiths and his team are unable to determine the age of these creatures without specimens. Given the lengthy lifespans of Antarctic sponges, it's conceivable that this ecosystem has existed for an extended period. While the rock may have initially harbored life long ago, ongoing currents may have continually introduced new organisms over the centuries. Elon Musk, along with the researchers and others involved, remain uncertain whether the discovery of this rock represents an anomaly or if similar ecosystems thrive beneath the Antarctic ice. These animal populations might not be isolated occurrences captured by chance when the scientists placed their cameras on the rock. They could be prevalent sites on the seafloor beneath Antarctica's ice shelves. With a vast expanse of 560,000 square kilometers comprising these floating ice shelves, there could be ample space for such ecosystems, equivalent to only a space the size of a tennis court, which has been explored by scientists through earlier boreholes. Therefore, it's plausible that numerous such communities exist, yet to be uncovered. This marks the inaugural documentation of a hard substrate community, a boulder community, deep beneath an ice shelf, challenging previous hypotheses about the types of life capable of enduring in such environments. The researchers speculate that this colony could be positioned up to 1,500 kilometers upstream from the nearest source of photosynthesis based on local water currents. However, without the means to gather samples of these species, a formidable obstacle in itself, researchers remain limited in their understanding of these animals. Other organisms are known to derive nutrients from glacial melts or compounds from methane seeps. Moreover, utilizing a substantial hot water drill, researchers stumbled upon a hitherto unseen ecosystem thriving within an underground river beneath the frigid surface of the Larsen ice shelf. This clandestine habitat lies within a sizable chamber approximately 1,640 feet, 500 meters, below the ice's surface. Initially identified by an unusual groove in a satellite photograph of the ice sheet, scientists were astonished to find the underground structure bustling with life. Upon excavation, the crew uncovered tens of thousands of small amphipod crustaceans, prompting jubilant celebrations among the researchers. Scientists have recently achieved a comprehensive understanding of the seafloor surrounding Antarctica, delving into its deepest point, the Factorian Deep. Discovered as recently as 2019 through a new map of the Southern Ocean, the Factorian Deep plunges to approximately 24,400 feet, 7,437 meters, below the ocean's surface, equivalent to the height of 17 stacked Empire State Buildings. Prior to this revelation, scientists were largely unaware of its interactions with the adjacent seafloor. This groundbreaking map, spanning over 18.5 million square miles, 48 million square kilometers of the seafloor, integrates data from more than 1,200 sonar readings, predominantly collected by scientific vessels. The detailed seafloor map serves as a vital tool for researchers in identifying potential hotspots of marine life, such as seamounts or underwater mountains. To unlock the secrets of these animals and their habitats, close interaction is imperative, emphasizes Griffiths. However, time may be running out. Despite being concealed beneath half a mile of ice, this rock faces escalating jeopardy due to the impacts of global warming. The potential collapse of sizable ice shelves threatens the loss of this distinctive ecological niche. The Thwaites Glacier in Antarctica, ominously dubbed the Doomsday Glacier, has recently been observed clinging precariously to the seafloor by underwater robots. Once detached, its demise may occur sooner than previously anticipated due to its rapid movement and a significant surge in ice loss during previously unrecognized phases of swift retreat. A new seafloor map encircling the glacier reveals a history of its movement, marked by parallel grooves carved into the ocean floor over centuries. Researchers caution that intensified heat resulting from climate change could trigger similar rapid melting events in the future. Thank you for joining us for another episode. While you're still here, be sure to click on the thumbnail for more incredible videos.